The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. Welcome to this Friday's TopSolid Perspective webinar. We'll get started here in just a moment. While we're waiting, let's maybe run a little simulation, talk about what this webinar will be all about. So in today's webinar, I figured we would take kind of a different look into TopSolid. As opposed to focusing on machining specifically, we're to focus on the idea of what I'm calling process manufacturing. So in today's little sample, you can see I have 3 setups done, or 3 operations being done on my little Haas machining center here. We have my op 10 on the left, which is just kind of where a few holes so that I can throw it on my riser plate on the middle op there to machine the first side of the part really. Then we're going to finish the part in a set of soft jaws in op 30 on the right hand side vise. The goal today is to kind of show you guys how I design the soft jaws. Okay, so again, focus on process manufacturing. So without further ado, let's go ahead and get started. So to begin with, I'm going to go ahead and close out of that machining, and I'm just going to start by opening up my main fixture design here. Okay, just a quick shout out to my team who's also on the line with us. Again, for those of you who have not attended our webinars before, there should be a section in your GoToWebinar interface where you can ask questions, make comments. The team will stand by to answer them or direct them to me if needed. So here we go. First thing I want to talk about in this little sample is what you're looking at on the screen. So this is the main assembly for my fixture, or my fixturing setup for this job. This is made up of a ton of standard components and custom where it needs to be custom. So what's standard? Well, my vise assembly is standard. How do I access my vise assembly? That's a great question. If you've seen my webinars before, you know I'm a big fan of using saved searches, especially for items that I use a lot. And for example, my 6-inch Kurt vise here, I use that a lot. So I have a little fixtures folder here. In my fixtures, you see I have a quick search for vices. If I double click on that, there's my vices. I have my little custom 5-inch round vise. I have my standard HD 690 6-inch Kurt vise that's got the hard jaws on it. And I have another one configured with the soft jaws. I can just drag and drop those in, assemble them, move on. Okay. From there, I'm using a lot of standard components as well. For example, my socketed cap screws, my washers, screws, dowel pins, what have you. So if I look in my ANSI folder here, I have quick access to my cap screws. Again, double click to run it, find the type of screw you're looking for, drag and drop it in, assemble it, move on with life. Same thing with washers, same thing with my dowel pins. Okay, so there's all my washers. If I go look at my dowel pins, there's all my dowel pins. Okay, so again, you're seeing that I'm really using the heart of TopSolid by using the automation TopSolid provides out of the box. These are all standard components. They ship with the software. They're available to anyone using TopSolid Professional or higher. Go to town. Okay, now let me correct myself there. The Kurt vices do not ship with the software. I downloaded those from Kurt's website and just made them a library object. Okay, so now moving forward, we now have our op 30. Pardon me, our op 20. In our op 20, this was an in-place design. So I made my little riser plate here, made it custom so that it would hold my block that I did my counterbored holes on. Now we go to op 30. Op 30 represents the way the part looks after machining from op 20. And if you notice, that stock model has a lot of detail in it for as machined. And that's because I pulled this stock model directly from the op 20 machining file. We'll talk about that here in a minute as well. Then we have our soft jaws that are made directly from that machining operation. Now, as we all know, documentation is key in the world of manufacturing. So not only can you build assemblies for it, but you can also document it. For example, here I made a just quick exploded assembly view of it, blew up on my focus today, which is the soft jaws. You can see down here I added a bill of material, lists everything, quantities, weights of things, the materials they're made of, all that kind of fun stuff. To show you how the exploded assembly was made, I can go and open the exploded assembly document. With TopSolid, you have a lot of power at your fingertips, and it makes documenting things really simple. For example, when I made this exploded assembly, and this took me maybe 5-10 minutes to put together, when you're done with the exploding, you can ask the software to automatically make a mounting animation for you. What would you use it for in this case? Well, to tell the guys on the floor how to put everything together. Because maybe it's a complex assembly. Maybe you want to showcase that this is how everything works. This can be saved off as an AVI file, an MPEG file, or you can save this into a viewer file format, then use the free TopSolid viewer on the floor to go completely paperless. Why not? Okay, so let's now take a look at what it takes to create this. Okay. At this point, what I want to do is I want to focus on my soft jaws. Okay. Prior to doing that, I want to kind of set the stage of how I think when I'm designing for process manufacturing. Okay, I think by operations, and I think any of you out there that do multi-setup machining like this, you think by operation as well. So in my op 10 here, this is my machining. Notice this is the machining for op 10. It's by itself. It's on the same Kurt vise. It has my machining operations. I then have the machining for op 20. This is on my riser plate to capture my op 20. Okay, and then we'll do our op 30 programming once we get our soft jaws put together. Okay, so in looking back at my fixturing, I designed this first, this second, this third, because again, order of operations, right? So here we go. I'm going to close what we don't need. I don't need my op 10. We'll keep op 20, but let's start by deleting that, and we'll delete this assembly. So now this is back, ready to rock, ready for us to build our soft jaws. So I'm going to build my soft jaws down here in this folder just to illustrate the steps that I would take. The very first step I would take is in my op 20 machining file, because in order to have the stock in the actual state it's going to be after machining op 20, I had to do the machining of op 20. And here, while it's not with the rest of the fixtures, I want to explain why I do it this way. Typically, when you're dealing with ops like this, you're not so much worried about collisions between the different setups. Usually the stuff is far enough away from each other, you don't have to worry about it. And even if it's not, when we do our final production version, we can check for collisions at that time, make any tweaks we need to right then and there. So here I did all the programming needed with my collision avoidance turned on based on the fixturing that's important right now, which is the riser plate and those screws. Okay, from there, all I'm going to do, come up here to the top of my operations list where I see my machine part 2 listed. I'm going to right mouse button click, go to others, and I'm going to choose extract machine part stock. This is going to take that stock model and export it as its own individual part document. Now, if I look at the history tree, you can see it says base shape creation. This is parametrically tied to the machining of op 20. Now, I'm going to teach you a magic trick here. First thing that I do personally, I right click on the part, go here, and I go to Basify. What that does is that breaks the associative link back to that op 20 document. And the reason I'm showing this to you is not for a simple project like this. For a simple project like this, you could totally leave it associative. But if you're doing a really complex project where each operation has hundreds of machining operations on it, you may not want this stock model to be parametrically linked back to op 20, and here's why. Let's say you go back to op 20 and you just tweak a feed rate or you change a depth of cut on something. The end resulting stock model is identical, but because TopSolid doesn't know that, if it's parametrically linked, that means op 30, op 40, op 50, everything downstream that's still, or forward I should say, that's still related to it, will have to regenerate. So you're recalculating toolpath perhaps unnecessarily, okay? If you change something severely in op 20 and this model had its associativity broken, you can always do a compare and replace the one stock model by the newly updated stock model and then update everything forward so it puts you again in that driving position. Okay, so with this associativity broken, let's go ahead. I'm going to move it down into my documents down here and I'm going to call it what it is. This is stock from op 20. the next thing that I'm going to do is I'm going to prepare my stock for my op30. So the way I'm going to do that is by building an assembly. So I'm going to start by right-clicking, making an assembly. In this assembly, what I'm going to do is I'm going to call this stock for op30, and I'm going to take my original part. I called it a port alignment cover. This is another fictional part brought to you by TopSolid. It's just, again, a sample part, okay? But it's got some fun features in it. So I brought that part in, and now I'm going to bring the stock model in, and I'm going to assemble it. I'm going to position it. So I'm going to take that, oops, I got to be in my positioning, forgive me. I'm going to take that to there. That's perfect. I'm going to flip it over. And then why not, let's align this with that. Flip this up. We'll take this planar face here to that face there. Notice the model turns blue. That means it's fully positioned. Now, from there, I'm going to hit save. The next thing I'm going to do, this is all said and done, right? I'm going to go ahead and take this, create my MPS file so it's ready for when we go to do our machining. So I'm going to go make my machine part setup document out of this really quick. I'm going to disassemble, of course. When I come into here, I take the time to name everything for a reason. So here's my stock from op20. If I drag and drop that right onto my stock type here, it's a little power user trick. It automatically switches to user stock and puts it in the right field. Okay, so now that's ready for machining. I'm going to close that. Next, it's time to make the soft jaws. And now here is where I'm going to really teach you kind of, I don't want to say it's a hidden trick, but really it's something I think only advanced users are aware of. And that's something called background documents. I want to build an assembly of my soft jaws. And I want my assembly to be able to use this assembly to build the correct detail into the soft jaws. However, I don't want this assembly to actually really be present in the soft jaw assembly. And that sounds confusing at first. But the reason I want that is because I want to be able to then take my soft jaw assembly and include it in my main assembly. I want to be able to include it into anywhere I need to use it without dragging this along with it. Because maybe I just want to machine my soft jaws, right? So this little step I'm going to show you is a way to manage that. Okay, so let's do it. I'm going to go here now, make an assembly. I'm going to call this soft jaws for op30. Now, what I'm going to do with my soft jaws for op30 first is I'm going to go to my 7 icon file, and right here you have something called a background document. Background documents work based on files that are open. So I can click this. This is going to show me every open file, and I'm going to go to my stock for op30. I could also use directly the stock model here. Doesn't really matter, okay? As long as we have it in here. And what this does is this includes that part based on its physical position in its document into this document. It's there. I can reference it. I can model off of it. I can do all sorts of things, but it's not considered part of the assembly. That's the key here. A background document is there, but it's there for processing. It's not there for documenting. Okay? Now, just to further this discussion, maybe I'd like to have a frame from this document show up in here on this background document. To be clear, this won't be a publishing. In fact, the way background documents work is only things that are visible will show up inside the document where it's referenced. So for example, if I go here and I add a frame, just frame by 2 points, why not? We'll do a little midpoint between point A and point B, that's perfect. We'll say X is X and Z is Z, just for fun. There's our frame. Because it's visible here, if I go into this assembly, it's visible there. It's that simple, okay? Now, from there, we want to build our soft jaws, okay? And just really quick to point something else out. In my entities tree, again, you're all familiar if you're TopSolid users with what the entities tree's job is. It organizes everything for you. You'll notice there's a new entry here called background documents. You can turn on and off those objects, okay? So now, how do we make the soft jaws? Well, my soft jaws come from a library, okay? So I have a library called soft jaws. This is a driven family of parts, which means that I'm using the TopSolid family documents to control this, but it's with a twist. For example, if I drag and drop this in, Sometimes, let me start by saying sometimes I position using a wizard. In this case, I don't care about a wizard, so I'm going to cancel my wizard. Now I'm going to give this a name. I'm going to say, you know what? Let's call this the fixed jaw. Okay. For my height, I don't know which dimension is my height. That's this one here. You can click on it. It'll highlight there. If I click here, you see it highlights there. If you remember what these are, you can of course hide that image. Okay. So for my height, I'm going to say this is 2.5 inches. For the thickness of this, I'm going to say this is 2.25 inches. Okay. And we'll say go. And then I'm going to call this one the moving jaw. And just to be different, I'm going to make this 1 inch 875, just to have two different size parts there. Okay, so now we have them both in there, and now we want to position them. So this is just standard assembly positioning. So here I'm going to take this front face of the part there, pardon me, this face, to that plane. I need this to be flipped over, so I'm going to double click on my little balloon right there. I want to then flip this part over. And for those of you who don't know this, I'm holding Alt down right now, left clicking and dragging to rotate the part dynamically by itself. So I'm going to take the top of my jaws to right here. Perfect. And then we're going to offset that maybe 1/4 inch. Let's see, which way did that go? I think that went down. So let's double click on that arrow to flip it the other way. And then finally, I'm going to take this plane from the frame there, and that's a published frame from my library, to there, and we have our soft jaw where I want it. Now, the last thing I want to do is I want to take this plane and offset it. So I'm going to say 1 1/8. Oh, went the wrong way, invert that, perfect. Now my soft jaw is exactly where I want it. Perfect. Now I'm going to repeat this for this part, right? So I'm just going to go straight to positioning, grab, relate to there, right? This is that plane. I'm going to flip that over. Just a quick little note here. So as you're adding more and more constraints, and I have included less positioning on, so all these are in the same positioning group, sometimes these balloons can get a little overwhelming. Okay, so I'm going to show you a trick here in a sec. First, I'm going to offset that maybe 1 inch. That looks right. I like it. So now I'm going to come up here and turn off show constraints. That's just going to hide the existing constraints while I continue adding additional constraints. For example, I want to have this, based on this face here, I want that to be there. We'll flip that over. This plane here is going to go up to that plane there. Perfect. If you want to bring them back, click there to bring them all back. Modify them as you will. So now our soft jaws are positioned. Again, that background document is there to reference, okay, but it's not there in the assembly structure, okay. Now, next step is we want to actually cut this shape into our soft jaws. So I'm going to go build a sketch. Now you could do a trim, you could do lots of things. I like sketches. It's just my personal preference. So I'm going to grab this edge here. Notice it went all the way around. It's following the tangencies. Perfect. Get out of that sketch. And now we're going to go to the modeling tab. And again, I'm doing this as an assembly feature. Trim on profile. I want to trim this and this, right? You can see I have trimming in 2 directions on. So I'm going down nothing and up some distance just to cut it out. And now a message is going to pop up when you do this. It's going to say the following parts are going to be derived from modification. This is super important. Those soft jaws, remember, came from a library. In order for you to modify a library object, you have to create a derivation of them. A derivation is a local copy. That local copy keeps all of the properties of the original library, but allows you to then apply further modeling steps to it. Okay, so we're going to click OK. And this is again all being managed by the PDM. If I go back to my entities tree here and I turn off my background document, you can see that's been cut out. Okay, I'm gonna go ahead and hide that sketch while I'm at it. I'm gonna turn the background document back on, and now I'm gonna do an in-place edit of my part to show something else. So if I right click on this, I can go to in-place edit. You could double click on it to do an in-place edit as well. Here I want to talk about another thing. So because the background document existed in the assembly file, it now exists in the part file as well. I can turn it off there. Notice that the cutout is not there, and this is super important. Here I want to talk about synchronizations. Because this jaw was a library file, it was bottom-up included, and then we created an operation onto it. That operation created the derivation. That operation created synchronizations now between documents. Okay, again, those synchronizations are controlled automatically. You see them right here, and you see they're grayed out. And the reason they're grayed out is because I have an option turned on in Tools Options within Assembly to edit before inclusion. And what that means is I want to edit this part prior, by default, to any operations being done. Okay, this button right here, right at the top, allows you to swap back and forth between the two modes, before inclusion, after inclusion. Okay, the reason I want to go after inclusion in this case is because I want to add further clearance here. So I'm going to go turn on that background document again. I'm going to start a sketch there, turn my background document on just for visualization. I'm going to go draw just a quick line. I just want to create some clearance underneath where this drilling is going to be so chips have a place to go. Okay, plus I don't want my tool to drill into my soft jaws. So let's go here. We're going to just use a quick little thicken command. No, it's not magic. It doesn't know automatically the sizes. It just remembers the previous size. So when I built this sample, that was the size I typed in before. Now from there, we can go ahead and create a quick pocket. So here we're just, again, clearing out underneath that. Done. Life is good. Soft jaws complete. Okay. Now, before we move on to using the soft jaws and deploying them, I would like to also show you how to quickly document these. Because again, part of manufacturing process design is not just the 3D modeling, it's also creating drawings so you can document them. You can dimension them, you can annotate them, you can do whatever you need to do to them. Because these objects come from a library, I used another awesome TopSolid feature called Predefined Drafting. Okay, so I can just simply right click on one of the faces of one of my jaws, go down to others here, and in here you're going to see Predefined Drafting. When I click that, you're going to see something cool happen. TopSolid automatically created my drawing for me with some dimensions, with some views already created. Here I'm doing a local section. You can see I have some dimensions for the standards of the spacing of my counterbore holes. You can see the cutouts now put in here. Again, this drafting comes from the library itself. There's a standard drafting in there. Okay. And now you can go and add whatever details you need to document this. Maybe you're not overly concerned with too much information here, but you want to give the setup guy some basic things they can check. For example, they need to know that this is to be 7/8 of an inch off the front edge of the jaw. Okay. Maybe you want them to know that that radius is that radius is that radius is that, who knows? You guys add the dimensions and the annotations that you need. Okay. Perfect. You can do that for the other one. That's documented, ready to go. So now let's use this in our assembly. So let's go all the way back to our pack fixturing assembly, and we want to make sure we can use our soft jaws in there. Now, I made a mistake, but I'm going to live with my mistake and just kind of show this to you on the fly. So if I go to my soft jaws here and I drag and drop them in, they're going to include into the positioning group for this automatically because this was the last positioning group made, and I want to put these in. You'll notice there's two frames here and here. I put those there in my library to make position of these faster, but you don't see the frames here. So my mistake was I forgot to inherit my publishing. So I'm just going to right click on each jaw really quick, go here to inherit publishings. For those of you that are not familiar with TopSolid that are watching this presentation, what is a publishing? So a publishing is you telling TopSolid that I want this specific information, frame, plane, sketch, surface, whatever, to be included when I include this object into an assembly. In TopSolid, we don't include all of the history when we include objects into the assembly. We keep everything extremely lightweight. We use publishings as a way to allow our users to choose the information they want to bring forward. Okay. So now that that's done, now I can go drag and drop this in. Now you see the frame, so I can go straight to frame on frame. It's awesome. I can click that to that. Just to illustrate, we can click that to that. Done. Our soft jaws are now in our assembly. I'm going to also take my stock for Op30 assembly and include that in here. And the reason I'm even bothering is because, again, we make a drawing out of this, right? Because we need to document this fixture. So let's take that bottom face to that face. Perfect. And then let's just take that cylinder. Oops, I got out of my command. Sorry about that. Let's take that command to there, and we're done. Okay, so now we have our fixture fully designed. We'll go ahead and hit save. I'm going to close everything I don't need. So I'm going to close everything but this. So close all documents but this one. We'll save whatever needs saving. And now from here, we're going to incorporate this into the production machining, because now I want to take all machining operations, throw them onto my fixtures, check for collisions, resort tools, do whatever it is you need to do for production, right? So to do that, here's what we're going to do. I'm going to start by first deriving this assembly. And this may be a new concept for people as well. So again, a derivation makes a copy downstream. I'm just going to put it in my documents of that entire assembly. You can choose what entities you want to derive, what parameters, and so on. Okay, so anything that gets changed in our main original assembly will carry forward to this, but anything we change in here does not go backwards. It's one direction. Okay, the reason I'm doing this is because I now have my fixtures laid out exactly as I want, but I don't want to have the parts present anymore. So I'm going to use a fun little command here called assembly removing, and remove what I don't need. I don't need those assemblies. I don't need these screws. Okay, so now they won't be considered part of the assembly anymore. If I show this in the project tree here, you can see it says my pack fixturing derived. I'm going to say for production, because it just helps me understand what it is that I'm looking at. And now the last step, let's lay out our final production machining. So we're going to go here. We're going to go and make a new machining file. We're going to use Haas VF6. First thing I want to do with my Haas is I want to include my fixtures, right? So I'm just going to drag and drop that assembly in, switch to inclusion. Here we see the entire thing. I want to position it based on frames. I know that the absolute frame of that document will work to the absolute frame of this, which is my machine 0 in this case. Okay, so that's sitting exactly where I want it. Done. And this is going to be part of the table. Now, I'm going to take this opportunity to show you another trick. If I go back to CAD mode, if you right click on the inclusion when you include your fixturings and you go to edit inclusion, right here you can choose which rigid group things go to as well. So you can say that this inclusion should be part of the rigid group of the table. This is for simulation purposes, so that if the table moves, your fixturing moves. Okay? Now, if you recall, all of my machining operations exist right here. Okay, so these were the pre-production versions. Maybe, maybe I programmed my op 10 separately, my op 20 separately, my op 30 separately, just to prove them out. And now I'm ready to do the production version. So I want to use everything that I've already done. So I'm going to include the machining file for op 10 as an NC part inclusion. What this does is this allows you to assemble in the work that you've already done. So for example, I want to put that there. I want to put that face there. Oh, we'll say against the fixed face there. And that to my stop right there. Done. Let's go back to machining mode here. And you can see there's all the toolpath. It's already ready to rock. We can even take our 0 here, edit it right away, make it 54. You could move it to a different spot if you want. Maybe you have a better spot for picking up your 54. You turn off automatic positioning. You can go pick the fixed edge of the vise, whatever you want. Okay, but that's going to be 54. I'm now going to go take op 20, drag and drop that in. Again, same thing with all my toolpath. I'm going to pop that right there. I'm going to say put that in there, put that in here. In this case, you saw the screws came with it. That's because in the MPS file or machine part setup file for this, I had included the screws in my machine part setup document. Okay, so they're part of it. Now we're going to go ahead and validate that positioning. That's now going to bring all that toolpath over. So it's just running a quick recalc on it. Now from there, again, just to set up for production, we're going to set this one here to 55. Perfect. And lastly is the op 30. Now, normally Op30 hadn't been programmed yet. You would, of course, program Op30 first, but because this is a webinar and I try to keep my webinars right around the half-hour time frame, I'm just going to bring in the already programmed version. And again, we're just going to position it, and off we go. So we can pop that in there. We can toss this down to here. Align that with that. And you're done. Let it recrunch. You can now sort the toolpath any which way you want to sort the toolpath. You can set, of course, your work offsets the way you need to set them. You can check for collisions between all operations now. You can do everything that you need to do at a production level. I'm going to edit my origin here as well, make it a 56, and you're done. Okay, so again, the goal here, again, was not to focus too much on toolpath today. It was just to focus on the process of manufacturing and to show that not only can you create and control your toolpath, of course, in TopSolid, but you can create everything else that goes along with that manufacturing process. You can engineer really, really complex things really quickly. You can capture your company's knowledge of fixturing, your company's knowledge of componentry, make it so that it's super simple and efficient to deploy. And then you have the added bonus of being able to check for collisions, doing any of that type of stuff as well because of the integrated machine simulation. So at this point, we are rocking this out right at a half an hour. Is there any questions that my team has not been able to answer? Let me look over here really quick, see if there's anything that I can answer. I'm just going to read through a couple of these. Not seeing anything. It seems that seems like the team was very good at answering, so that's awesome. Cool. Well, with that said, just as a reminder, this webinar will be available on TopSolidUSA.com shortly under the webinar section. It's also available on our YouTube channel once, again, I post it, and that should be after lunch today. I hope you all have a wonderful weekend. Stay safe out there, and check back soon for the next webinar. Have a great day.